Welcome to section C. In the previous sections, we have seen how to transform equations from time domain to S domain. Similarly, we can also transform circuits from time domain to S domain. And in this section C, we will see how to transform an RLC circuit from time domain to S domain. And in section C, we will focus with no initial condition, without initial condition. So when we are transforming the circuits from time domain to S domain, the main thing we need to do is transform each component, each source and component in the circuit from time to S domain. If it is a DC source, then the Laplace transform of the DC value is just over S. Okay, the value of the source over S. If it is an AC source, we can use this expression. Okay, and we can obtain these expressions from the Laplace transform table. Now, how about RLC components? For R, the transform is straightforward. It's exactly the same. When R in time domain is still R, L inductor in time domain becomes S times L. Okay. And capacitor in time domain becomes 1 over, sorry, in S domain, it becomes 1 over SC. Okay, now let's look at an example so that this becomes a lot more easier to understand. Okay, let's say we have a circuit like this. Okay, this is a circuit. There's a source and there's a resistor and there's an inductor, and the current direction is given here. This is the current. Okay, now our goal here is to do two things. One is to draw this circuit, okay, transform and draw this circuit in S domain. Okay, that is the part A. And then B, find the transfer function IS. So once we draw in S domain, it's very straightforward to do this. Okay, let's look at it, how to do. Okay, here is the circuit. Okay, I've reproduced the circuit here in time domain, and I'll explain how to transform it into S domain. So we just draw back the same circuit. Here we have plus minus. Then we have a resistor and an inductor. Okay, the circuit looks exactly the same, except the values will be different. Now the source in time domain is 50. In the S domain, it will become 50 over S. Okay, resistor, there's no change. 10. Here is also 10 ohm. And for inductor, it becomes SL, if you still remember. In the previous slide, it showed us. So 2 becomes 2S. Okay, just multiply by S. Okay, and then we also indicate the current direction. Current flows in this direction. And the current is now the transform of this current, which is IS. Okay, so we see this is similar to the answer given here. Okay, we have 50 over S, IS, the resistor, no change, and the inductor is 2S. Okay. Next step, how to find IS? It's very straightforward. We just use Ohm's law. If you use Ohm's law, then we can express the IS. IS is basically the source divided by the total impedance in the circuit. Okay, and the source is given here as 50 over S, and we divide by the total impedance, which is, we just follow the current and we add up all the impedance. Then we will get the total. So there's 10 here, so we put 10 and then plus 2S. Okay, so this is the S domain expression for the current, the Laplace transform of the current. Okay, you can further simplify it to be like this. Okay, multiply each term by the numerator and denominator by s, then you can simplify it like this. Okay, but this is also sufficient. Okay, so that's all for section C. Thank you.